The Sobel edge detector. The idea is to find edges in the image. The edges can be remembered in many directions, but the core idea is to understand then that an edge is a rapid change in intensity in the image. Therefore, we will be looking for very rapid change in intensity in image. So here is an edge. You can see that the area of the edge is the area of high gradient. There is very rapid change in intensity in the image, and we want to capture this idea. So we use kernels to do that. We calculate the gradient in the x direction. We call that gx. Namely, if we move in this direction in the image, or if you want in the other one, if you move in this direction or this direction, you will see very high change. This is for vertical edges, where for vertical edges, the intensity on both sides change very rapidly because you move the edges, very high intensity change. So the gx is the gradient in the x direction and it detects vertical edges. The gy is the same just for the horizontal edges. It detects gradient in the y direction. The same idea. An edge is a rapid change in intensity of the image. Now, we calculate for each pixel the gx and gy. Now we want to get the total magnitude of what is the probability, the score for this exact pixel that we calculated those gradients. What is the score? Because you remember that the edge doesn't have to be vertical or horizontal. It can be in many directions. So using gx and gy, it's like component of a vector. We want to calculate the magnitude of the summed vector. So like in Pythagoras, we can calculate gx squared plus gy squared, taking the square root, and we'll get the magnitude for this specific pixel and do it for each pixel. What is the gradient on u based on x and y directions of gradients? You can also calculate the direction of the vector. In the same idea for vectors, you'll need the arctangents of gy divided by gx. So you can know what is the direction of the edge. Now, this is just an example. You can see this, and we can apply the Sobel operator to detect the edges. And you can see how we detected the edges in the image conceptually. So this is it. This is the Sobel edge detector. We want to detect high intensity gradient changes. We were calculating the x and y direction in order to get a summed vector. We calculate the magnitude. We can also see the angle using arctangents of gy divided by gx, and by this we're getting the edge. Just to tell you the process is usually starting with a color image and then turn it into a grayscale image. After that, usually there is some blurring in order to get away from noise in the image. Remember, noise is very problematic because noise is a random areas that may be high intensity changes because it's totally random. So because of noise, we can detect noise as edges. So let's remove it using, for example, the Gaussian blur before we apply the kernels gx and gy. And after this, from color to grayscale, grayscale blurring, removing the noise, now we can use those kernels to calculate the gradients. And after this, we calculate the magnitude and we can calculate the angle, and this is how we detected edges using the Sobel operator. Thank you very much, and that's it.